Now, ladies and gentlemen, it is time to start the briefing of Mitsubishi Electric Corporation's briefing on R&D strategies. Thank you very much for joining us today. Let me introduce the speakers of the day. Executive Officer and CTO, Tomonori Sato. And Executive Officer in charge of Intellectual Property, Vice President of Corporate Research and Development, Toru Oka. Now, I will hand over the microphone to Sato-san. Thank you very much. I am Sato, Executive Officer and CTO of Mitsubishi Electric Corporation. Thank you very much for joining us today for our briefing of our R&D strategies. Without further ado, I will just jump into the content of my presentation. We have three parts, three chapters of presentations today. The first part will be covered by myself, Sato, which will be the overview of R&D strategy. And then I will switch over to Toru Oka, Executive Officer in charge of Intellectual Property, to cover development strategy for the technology domains to be strengthened and the initiatives for future growth. Let's turn to page 3. There are two main messages that I would like to convey today. Number one, in addition to our strong component technologies, we will continue to promote R&D for the digital technologies, which will enable us to continuously drive business growth. The second message is about our foresight technology development, which would fundamentally resolve social challenges. Foresight technologies are the term that we coined for the technologies with large impact for the society and the businesses. More visionary type of technologies, which we'll explain in the third part of today's presentation. Now, let's begin with the overview of our R&D strategies, page 5. This page shows the policies of our sustainability-related items at our group of Mitsubishi Electric. We regard realizing sustainability as the core of the cornerstone of our management. In the past, social issue resolution and business growth were looked at as trade-offs. However, we decided to employ concept of trade-on, which will be accelerated through innovation of circular digital engineering, eventually leading to realization of green, safe, secure, comfortable society with sustainability. Let's turn to page 6. And this shows the overview of our R&D strategy. And as you can see on the left, we have our component technologies, our strength, and then followed by digital technologies to be strengthened. The combination of the two will allow us to generate new value as well as sustainable business growth. The impactful technologies, the foresight technologies, will be focused on in our R&D. And then, together with our partners, we will promote co-creation to create new value for fundamental resolution of social challenges leading to sustainability. We continue to aim at green, safe, secure, and comfortable society by leveraging our strength and our technological prowess. Next page. This is about the domains to be strengthened in our R&D. We have multiple facets of businesses from home electronics to aerospace. And we do have the common foundational platform technologies, which will be promoted further for common usage so that we were able to efficiently enhance our competitiveness. And these are the 4 areas of technologies which support the component technologies as well as digital technologies. So those very strong component technologies will be further enhanced in the future, and leading cutting edge and characteristic digital technologies will be enhanced, as you can see in those 3 areas. We have the digital platform called Serenity, which enable us to obtain data, which will be further leveraged for the realization of a clean, secure, safe, and comfortable society. Page 8 talks about our R&D investment. We continue to invest in R&D and initiatives for creating new value that will strengthen our market competitiveness and support sustainable growth. On the right, you see our open innovation initiatives. In the co-creation areas, we plan to invest from fiscal year 25 to fiscal year 31, 100 billion yen in industry, academia, government collaboration-related R&D, and promote R&D in a timely manner. Exploration of R&D, green energy, exploratory researches, as well as demonstrations are within our scope. In order to accelerate the innovations to resolve social challenges, we will actively collaborate with startups and make active investment in that area so that we can adopt new ideas and technologies to maximize our impact to the society. Through such initiatives, we will strengthen our business competitiveness to ensure our sustainable growth. Page 9 talks about our global R&D. Leveraging overseas R&D bases as well as universities' networks, we continue to strengthen our basic research foundation. We also promote co-creation in North America, Europe, and Asia. You see some concrete examples. For example, in Europe, we are a part of the REACT project, which aims at optimizing energy demand and energy autonomy. We are also a part of Berlin TXL, which is a smart city development project using the former Berlin Tegel airport site. In Asia, we work with ITRI in Taiwan with the comprehensive collaboration arrangement for green energy. Through these initiatives, we plan to implement these technologies in the society earlier. In North America, in order to obtain innovative technologies, we work with American and other global major universities in close collaboration. Such initiatives enable us to have global perspectives in R&D, which will further enhance our efforts to contribute to the sustainable future of the society. Page 10 talks about our intellectual property. Our group holds nearly 70,000 patents globally. More than 50% of them are related to technologies supporting strong component businesses, the foundation of our business. Very important intellectual property assets. We will strengthen our patent holdings in that area to uphold our businesses, and within the top 3 holdings list is shown in the box. In 4 areas, as you can see, we are number 1 in terms of the numbers of patents held. In the digital technology domain, we are positioned within top 3 in some areas. We also strengthen our patent applications in the areas of AI, generative AI, and solutions to generate new value for our customers to enhance value of our component technologies. For example, in fiscal year 26, we aim at raising the proportion of AI and generative AI patents to be 15% of the total and 30% for the solutions patents. They will enable us to generate new customer value for the strong components and digital technologies to enable our stable growth. Next page talks about our efforts in standardization as well as communication of our research results. We strengthen global standardization activities and technology presence in alignment with business and R&D strategies. As a part of our business strategy, we will enhance activities to secure market superiority through rulemaking. Over 600 members, including key roles in international standardization organization, like the IEC Vice President, will present the direction of technological development globally. And that will be our indication to the standardization organizations. One example would be in the area of power electronics and power semiconductors. We have been a leader in initiating the IEC white paper, which aims at standardization and standard certification systems for the semiconductors for higher quality and efficiency. And in the industrial network area, we were very early in adopting TSN technologies, the evolving standardization area, to enhance convenience of our FA equipment. We continue to enhance our contribution in standardization and securing market presence. And we also present at world-class conferences, especially in the area of AI and securities. The evaluation at such conferences certainly motivate our researchers, and such presentations will find new audience for our technological prowess. We will continue to make such efforts. This concludes the overview of the first part of today's presentations. Starting from the second part, Oka-san, in charge of IP, will take over. Thank you very much. This is Oka speaking. Thank you very much for your attendance today. Let me now talk about the strategy for the technology or technology domains to be enhanced. Let's turn to page 13. As you have heard, we have a very strong technological prowess in the component technologies, which will be fused with foresight technologies as well as digital technologies to create new value for further contribution for sustainability. Let me first recap on the technologies which support our component business. Let's turn to page 14. On the left, you see power electronics and devices, mechatronics, air conditioning and refrigeration, and sensing. And these are the areas where we had differentiating enabling technologies for our component products. With such strong technologies, we have generated many products, as you can see on the slides. Going forward, we will leverage data from Serendip platform, as well as circular digital engineering. The components will be the starting point of acquisition of data and analytics, as well as generating value in the physical space. They will remain extremely important. Therefore, we will continue to strengthen and further deepen the technologies on the right to continue generating competitive components going forward. Next page talks about the use of data, which will be transformed into new value and solutions through digital technologies, which I would like to talk about. These technologies will be the enablers for what we aim at as circular digital engineering.
So please turn to page 16. Let me first start with our intelligent autonomous control technology. Based on our strength in various control-related technologies cultivated in the factory automation, building, air conditioning, and space industries, we will enable the integrated operation and management, as well as autonomous operation of large-scale systems that have many intricately linked components and systems. And this will enable green, safe, and secure and comfort environments in a wide variety of settings, including buildings, data centers, factories, and communities. For example, in buildings, neighborhoods, data centers, and factories, numerous systems work together in so-called system of systems, which require autonomous optimization. Mitsubishi Electric provides not only the components, but also the technologies which are necessary for autonomous control to manage the power, heat, air, and water systems, including the equipment that control them as a whole. And the key technologies for realizing such total facility management are indicated on the left. They include optimal control technology for complex systems, heat modeling and control technology for buildings, as well as lightweight blockchain technology. Optimal control for complex systems is a key technology for the speedy optimization of operational planning and predictive control of system of systems using mathematical optimization. In addition, automation and autonomization in factories will help alleviate labor shortages and improve the quality of work. On the right-hand side are technologies related to autonomization. We will focus on autonomous robotics control, LLM, high-precision positioning technology, and audio separation and recognition technologies. In a robot autonomous control, LLM, a robot motion plan proposed by one LLM is verified by another LLM to arrive at an optimal solution that can have the motion errors of robots. Now moving on to page 17. Next, I will explain our cybersecurity and cryptography technologies. Melco will leverage the cybersecurity and cryptography capabilities nurtured through our energy facilities and other critical infrastructure projects to defend against and also minimize the impacts of cyber attacks. Melco undertakes many projects that support infrastructure and industries which are essential to society. However, cyber attackers employ increasingly sophisticated attack vectors and technologies, and this is growing into a major social issue. So in order to contribute to the realization of a safe and secure society, we consider it extremely important to strengthen cybersecurity and encryption technologies. In order to enhance our ability to defend against cyber attacks, we will focus on attack detection, concealed search, and post-quantum cryptography, or PQC technologies, which are indicated on the left. Concealed search technology allows data to be searched while in an encrypted state. Our proprietary crypto technology based on functional encryption provides both security and convenience at the same time. To minimize the impact of cyber incidents, we have also enhanced our privacy protection technology, attack simulation technology, and dynamic microsegmentation. Dynamic microsegmentation identifies network segments that are not affected by cyber to ensure continued secure communications and facility operations. Now, please turn to page 18. This slide shows our activities in the fields of AI and generative AI. Melco will deliver a highly adaptable and reliable AI that can respond to rapidly changing environments, such as maintenance and manufacturing sites, based on our strength in physical models and simulations developed in our component business, and Compact AI incorporated into many of our products under the MazeArt brand. And this will enable high-speed, high-precision inference and automation of site-specific and small amounts of data, as well as flexible support for complex operations and tasks, thereby reducing the burden on users and increasing efficiency. At maintenance and manufacturing sites, devices perform complex operations, and the operating environment is constantly changing. On the left, you see neurophysical AI, compact real-time technology, and environment adaptation technology, and these enable highly accurate and reliable inference and control. Meanwhile, neurophysical AI is a unique name that describes the characteristics of Melco's technology, which enables high-precision control with just 1/10 the training data of conventional systems by utilizing physical models and simulation technology for equipment and systems in factories, buildings, and plants. When using AI for infrastructure maintenance and manufacturing, reliability and explainability are extremely important. And to achieve this, we will focus on AI that works collaboratively with humans, distributed collaborative agents, and performance assurance technology. In distributed collaborative AI technology, an AI agent is installed on each manufacturing facility in a factory. It shares information on the content and status of tasks with other AI agents that oversee the entire system, and together infers the optimal system-wide solution to execute complex tasks such as variable mix, variable volume production. Now, please turn to page 19. Moving on to the third section of the presentation, where we will discuss initiatives for further future growth. So please turn to page 20. Let me illustrate our future efforts in foresight technologies. We define foresight technology, as I said at the outset, as technology that is developed with foresight in order to deliver a significant impact on society and business. The company aims to combine new and innovative technologies with existing technologies to deliver huge impacts on society and business and contribute to the resolution of social challenges. We will start by analyzing the technological potential, social value, and other attributes to identify themes. And we also want to take on the challenge of creating a new value. I will share some concrete examples now, so please turn to page 21. Case 1, or the first example, is photonics-electronics convergence. With the rapid development of AI technologies, including generative AI, reducing power consumption in data centers has become a key issue. Melco has established photoelectronic fusion technology that can boost the computing power of data centers and significantly reduce power consumption at the same time, thereby contributing to the development of AI technology and energy conservation. As shown on the left, photoelectronic fusion technology replaces electrical connections with optical connections for inter-device data transmission, such as between GPUs and GPU and memory. Currently, as shown in the figure on the bottom left, only the connection between boards or substrates is optical using optical transceivers, and the rest are electrically connected, which consumes a lot of power. In the future, GPU-installed packages will be optically connected using photoelectronic co-packaging, and furthermore into the future, chips will be optically connected using optical chiplets. Although the results depend on facility conditions, we aim to increase power efficiency by a factor of 10 with co-packaging and by a factor of 100 with the optical chiplets. As shown under advantages of our technology on the right, we can realize high-density integration, high luminous efficiency, and high-speed modulation by utilizing the compound optical semiconductor technology that Melco has developed. We have a track record of manufacturing and selling EMLs, which are key devices for optical transceivers, and we believe we can take advantage of these strengths. Now, please turn to page 22. The next example is carbon recycling technology. Achieving carbon neutrality, we believe, requires efforts that are not just an extension of the past in order to reduce our dependence on fossil fuels. Melco focuses on carbon recycling technology as one means to achieve this goal, and we are promoting its development with several partners. We are working to establish an integrated EMS, or energy management system, that will reduce the cost of producing liquid synthetic fuels from CO2. The project will generate social value because CO2 emissions can be curbed by efficiently capturing CO2 emitted from factories and plants and reusing it as fuel. Various methods have been tried to reduce CO2 emissions, including hydrogen and electrification. However, synthetic fuels with high energy density are one of the most promising candidates. We believe that this process will allow the integrated management and control of electricity, heat, and chemicals to reduce production costs and foster social implementation. As for the advantages of our technology, on the right, Melco owns a wealth of technology and know-how in energy management that links components and systems such as power control, heat control used in air conditioning, and plant monitoring and control. So we are confident that we can contribute to resolving the issues of cost and efficiency in the production of liquid synthetic fuels. Currently, we are working with NEDO to promote the commercialization of SOEC co-electrolysis in a project. Please go to page 23. The next example is quantum-related technology. To realize a quantum future society in which quantum computers and quantum sensing are put to practical use, Melco will promote the research and development of quantum control systems technology to realize scalable quantum information processing and PQC, or post-quantum cryptography, in order to protect existing infrastructure. As for social value, we aim to achieve quantum entanglement between multiple quantum computers via optical networks, thereby virtually increasing the number of qubits, or quantum bits, in quantum computers and contributing to the advancement of computation and measurement. On the other hand, if quantum computers achieve commercial use, then current cryptographic technologies may be quickly decrypted. But we will prepare for this eventuality with post-quantum cryptography that will maintain and improve the security of infrastructure against such threats. The special advantage of this technology, indicated on the right, is that it enables high-precision synchronization of photons and transmission that maintains quantum entanglement using technologies for controlling the phase and frequency of light that Melco has accumulated through the development of high-power lasers and fiber to the home, or FTTH. As for post-quantum cryptography, we will utilize our proven encryption technologies, including lattice-based cryptography, to continue research and development of unique cipher systems, including the development for implementation in existing systems, as well as participation in national projects. So please turn now to page 24. This is a summary. Melco will promote research and development to derive sustainable business growth by leveraging our strength in components and digital technology to generate new value. We will also focus on the development of foresight technologies that can offer fundamental solutions to social challenges. And through such efforts, Melco will contribute to the realization of a sustainable society. So thank you very much for your kind attention.